बढ़िया टीचर्स प्रॉब्लम्स चुटकी में सुलझाएंगे, डाउट सारी जिंदगी से
Raj, I got your doubt. This is your answer.
समझ आएगा तो मजा आएगा। Vedantu, learn live online. To attend a free live class, download the app now.
Alright guys, so we are ready to go. Alright guys, so yes, we are ready to go now. Let's start with the discussion of the paper. Yes, so this is the first question here. It's a very easy question. The question says that there is a block of mass m connected to one end of a spring fixed at the other end having a natural length L0 and spring constant K. The block is rotated with a constant angular speed omega about the fixed end in gravity free space. So I'll draw the situation in front of you. What kind of situation it is, I'm going to show you that. So there is a spring and the natural length of the spring is L. So we have tied a block at the other end and we are rotating it in a circle with an angular velocity omega. Alright, a very simple question. So what will happen? This will go in a circle, and to move it in a circle, a force is required that should be acting towards the center. This force will be given by K into delta L, where delta L is the elongation produced in the spring. So the radius in which this block will be moving, this radius will be given by the natural length of the spring plus delta L. So these are the things that you have to keep in mind. Since it is a gravity free space, we don't have to consider the force of gravity also. So there is only one force acting on the block, which is K delta L, and this force will play the role of centripetal force. So I can equate this with m omega square into radius. Radius is L0 plus delta L. Alright, have a look at this equation. If you are able to write this equation, then you are done. The next step will give you the result. You have to just solve for the value of delta L. The question is asking for elongation in the spring, so you have to solve for the value of delta L. So how do we do that? We write K minus m omega square, alright, into delta L is equals to m omega square into L0. Alright, so the value of delta L will be given as m omega square L0 divided by K minus m omega square. So that will give you the result. So I guess we have one of the options like this, which says m omega square L0 upon K minus m omega square. Okay, this should have been K minus m omega square. There has been a misprinting here. Okay, these two options, they have K minus m omega, K plus m omega. So these two options are dimensionally incorrect. We could have eliminated these two options, but between A and B, there was one option with K minus m omega square. That was A option. So A option should be the correct one in this. All right. So a very simple question, I would say. What do you think, guys? Very simple question. All right, let's move to the next one. This question was from the chapter laws of motion, actually laws of motion and circular motion, in which we were making use of the spring force. All right, let's move to the next one. Now this question, again a simple one if you understand the situation here. So there are three charged particles that have been indicated in this question. One charged particle is having a charge of minus 2q, one is having a charge of plus 2q, and one is having a charge of minus 4q. Now by looking at the situation, can we decide that minus 2q and plus 2q, they are situated at opposite ends of a diameter? All right, I'll tell you how I am saying this. Just a minute. Yeah, so this angle is given to be 30 degree, this angle is given to be 30 degree, so that means it is a diameter. So these two particles, minus 2q and plus 2q, they lie on the opposite sides of a diameter, at the opposite ends of a diameter. Okay, so the electric field that minus 2q will produce at center will point in this direction. It's a negative charge, so it will produce electric field towards itself. The positive charge will also produce a field towards itself, and this minus 4q will produce an electric field towards itself. All right, now we can clearly see that the distances of all the three particles from the center is same, so the electric field will be proportional to the magnitude of the charge, which means that if I write the electric field of this charge as E, and if I write the electric field of this charge, it will also be written as E, because these two will produce the electric field of same magnitude, and this will produce the electric field of 2E. So overall we have two vectors of equal magnitude. So the resultant will point along the angle bisector, right? So this will be my E net. And how do I write E net? Well, E net will be written as 2E into cos 30. So that's the cos component of one vector, and we double this to consider the effect of both the vectors, right? Their sine components, they are going to get cancelled, so their cos components are going to get added. So we end up writing 4E into cos 30. All right, so rest is calculation. Actually, you can do it yourself also, but I'll just finish it. So 4e cos 30. So it is going to become 2 root 3 into E, and E is what? E is the contribution due to one particle. That was the minus 2q charge. So I'm going to write K into 2q divided by R square. All right. So this is your final answer, but the options are given in terms of 4 pi epsilon naught or epsilon naught. So you can replace K by 1 by 4 pi epsilon naught. The 4 will get cancelled. So I guess we are looking for an option in which 4 is not present in the denominator. Nothing is present in the denominator. All right. So C option should be the correct one for this question. Alright guys, again a very simple question based on the definition of electric field. If you are aware of how to write electric field due to a charged particle, which I'm pretty sure many of you are, right? This is something that nobody can falter upon, something that you study right at the start of 12th standard. So it was an easy question so long as you were attempting it with a peaceful mind, with a calm, relaxed mind. This question is certainly going to fetch you marks. Okay, let's move to the next one now. Again, a very simple question. Okay, a very simple question in which a graph is given to you. A process has been represented in the TV diagram. Okay, T on the x-axis, volume on the y-axis, and we have to figure out the correct PV graph for same process. I think this is one of the most easiest question that can get if you know how to convert these graphs. You know, something very easy. So let's talk about this YZ process. ZX process. Now ZX process is an isothermal process, right? ZX process is isothermal because temperature has remained constant. YZ process is an isochoric process. So I'm pretty sure that YZ process will be represented by a vertical line. Okay, so YZ process will be represented by a vertical line. In this, the vertical line is represented by ZX. This is definitely wrong. Okay, in this also the vertical line is represented by ZX. This is definitely wrong. In this there is no vertical line, so I guess, in fact, at least YZ is not vertical, so this is definitely wrong. So the only correct option is this. Okay, if you want, you can go on to further confirm that yes, this is the correct option. I would say that this is not advisable in the examination. If you are able to eliminate 3 options in the examination, just click on the remaining one and move to the next question, save your time. Okay, but if you are practicing this question at home, you will do yourself a world of good by figuring out that yes, indeed the process, the graph would have been like this. Like if no option is given to you and it's basically a subjective question, then if I ask you to represent the same process on a PV diagram, then try it out. You will end up making a graph like this. How this XY process, this XY line is a straight line passing through origin, so it indicates an isobaric process. Here we can see that XY represents an isobaric process, YZ represents an isochoric process, and ZX is a curved line. So we can say that it's representing a hyperbola, which basically means an isothermal process. Okay, but we need not go into so much detail in this question. The moment you check that ZY is isochoric process and you try to figure out a vertical line, the ends of which are marked as Z and Y, you do not find that in 3 options. You just cut these options, 4th one is the correct one. Alright, so very easy question, I would say, made easier by giving you such choices in the option. Okay, so let's move to the next one now. Now this question says that find the coordinates of center of mass of the lamina in the, now guys, this question, I would say it basically depends on your approach, whether this question is easy or not. Okay, let's try to do this question. Let's try to see how we can make this question easy. Now pay attention to the coordinates. Pay attention to the coordinates here. This is 0, 0, so this is origin. This is 1, 1, 0, and this is 2, 3, so this point is bound to be 2, 0, right? And since the y coordinate is 3 here, the y coordinate is 3 here, so I can say that like, and this coordinate is 1, 2, so this height is 1. So I can say that I can divide this figure in squares like this. Okay, I can divide this figure. Let's divide the figure into squares like this. So if this square has a mass, if this has a mass m, so I will assume that a particle of mass m is situated at the center of the square. So I have a particle of mass m here, I have a particle of mass m here, I have a particle of mass m here, I have a particle of mass m here. Alright, now next what we can do, we can collapse these 3 particles into one particle. We can condense this portion of the figure into a particle of mass 3m, and we will assume that that particle is situated here. Like let's say this is 3m, Okay, so overall the question becomes like this. We have a particle of mass 3m situated at what point? Situated at 0.5 comma 1.5, and we have another particle of mass m situated at 1.5 comma 2.5. Now rest is easy, right? You know the mass of the particle, you know the coordinates of the particle. So now it's a two particle system. You can figure out the location of xcm. How will you figure it out? You will multiply mass, that is 3m, with the distance, which is 0.5, all right, plus the mass of this particle, which is m, multiplied by 1.5 divided by the total mass, which is 4m. So we end up writing what? This becomes 1.5, this is already 1.5, so we end up getting 3 by 4, which is 0.75. so if I check only this coordinate, let's search for this. If there is only one option that says x coordinate is 0.75, I need not solve for y coordinate. I can straight away click that option, but unfortunately we have two options that says that x coordinate is 0.75. So to figure out the correct answer from between these two options, we will have to go for the y coordinate also. So let's calculate ycm also now. All right, yes, let's calculate the ycm. So ycm will be calculated by 3m into 1.5. all right, 3m into 1.5 plus m into 2.5 divided by 4m. all right, so once you do the calculation, you are going to get like this is 4.5 plus 2.5 will become 7 by 4, so that's 1.75. so A option will be the correct one. Okay, now could we have done something better? Like once we were able to find the x coordinate, do we actually need to spend time in calculating the y coordinate, or can we directly do something to figure out which one is the correct option from between these two? So yes, we can do that. I'll tell you how. This is a particle of mass 3m which is situated at at a height of 1.5, and the other particle is situated higher than that. Then ycm cannot be 1.5. It cannot be. Understand this. One particle is situated at 1.5, the other one is situated higher than that. Then how the hell can we end up, okay, getting a coordinate which is equal to 1.5? I'm talking about the y coordinate. We'll be definitely getting a value which is more than 1.5. So by that logic, you could have eliminated the B option even without doing any calculation. All right, so things like this or thinking like this is going to save your time in the examination. All right, guys, so I hope you got this thing. All right, I hope you are enjoying this session. People who have got exam in like tomorrow morning session, I would advise them to go to sleep. All right, to go to sleep, relax, go to sleep, get up with a relaxed mind and go attempt your paper beautifully. All right, and those of you who have exam in the second shift, they can afford to stay here, they can watch what is going on, but do not be affected by this, guys. All right, do not be affected by this. Whatever comes in this paper, that has already come. If it was something that you could have done, if like you think that, oh alas, I should have been in this shift as the paper was so easy, then you should take confidence from it that if this paper was easy, tomorrow's paper will also be easy. And if in case you find the paper difficult, or if you have come across questions in which you are not comfortable in this shift, then also rejoice, enjoy, like feel elated that the difficult questions have already come. So probably it's going to be your day tomorrow. All right, guys. With that thought, let's move to the next question. Now this question says, which graph correctly represents the variation of the relaxation time with absolute temperature? All right, now see, to address this question, there's one formula that you should be aware of. First of all, you should have a fair understanding of what relaxation time is. Secondly, you should be aware of the formula of the mean free path, which is 1 by root 2 into pi d square into number of molecules divided by volume. So d is the diameter of a molecule here. All right, so in this, like we are looking for relaxation time. So relaxation time can be written as what? Relaxation time can be written as the time spent between two successive molecules, between two successive collisions. All right, so this time can be calculated as mean free path divided by the speed divided by the speed. Now any kind of speed you write, all right, either you are thinking in terms of RMS or average speed or most probable speed, whatever kind of speed comes to your mind, the fact remains that speed is proportional to root t, right? Any kind of speed is proportional to root t. Only the constants keep on changing. Okay, whether you are discussing about RMS speed, whether you're talking about most probable speed. All right, so this relaxation time happens to be inversely proportional to the root of temperature. That's it. So from among the options given to us, if I draw a graph of relaxation time versus 1 by root t, then this graph is going to be a straight line passing through origin. So A option would be the correct one here. Now this is a question that some of you, many of you may not be able to do, because this is a formula, this formula is an uncommon one. Alright, I have seen students fail to recall this formula when required. So I'm expecting that this question is one question where student would have faced difficulty in the examination, but again, that's my opinion. Alright, I'm not saying that it's going to happen like that, but that's my opinion. Now let's move to the next question. Now this is an easier question. Okay, now if two capacitors C1 and C2 are connected in parallel, if they are connected parallelly, then their equivalent capacitance is given to be 10. Alright, which means what? If they are connected parallelly, equivalent capacitance is 10. So we can say that C1 plus C2 will be 10. So that is my one equation. If both are connected across 1 volt battery, then energy stored by C2 is 4 times the energy. Now energy stored by C2 will be written as half C2 V square. Alright, and energy stored by C1 will be written as half C1 V square. The statement says that energy stored by C2, that means this part, is 4 times the energy stored by C1. Alright, the energy stored by C1 is half C1 V square. 4 times of this becomes the energy stored by C2. That basically means, why have I used same V here? I should explain that. Why have I used same V here? Because the question says both capacitors are connected across 1 volt battery. I haven't even considered one value. I have considered battery of same EMF. I've indicated that EMF by V. So this basically tells us that C2 is equals to 4 times of C1, right? C2 is equals to 4 times of C1. If I put the value of C2 here, I end up getting 5 C1 as 10. So C1 is 2 microfarad, which obviously means that C2 will be 8 microfarad. So we have obtained the value of C1 also and C2 also. Let's see what the question says. Now when they are connected in series, I think that's a cakewalk now. Like, this is something that you all can do. Their series connection will give us an equivalent value of 8 into 2 divided by 8 plus 2. So that would be 16 divided by 10. 1.6 would be the correct answer. So A option, 1.6 microfarad will be the correct answer here. Alright, hope you got this. Okay guys, you are asking me to change the color. That's a difficult task. That's a very difficult task. Okay, I have done that. Hopefully it will stay like this only. Okay, so let me move to the next question now. Alright. Okay, now this question says a rod of mass 4m and length L is hinged at the midpoint. Alright. A ball of mass m moving with a speed v in the plane of the rod, which is perpendicular to the axis of rotation, strikes one end of the... Okay, now the situation is somewhat like this. Yep. The situation is somewhat like this. I hope this color is visible to everybody. There is a rod, the mass of which is 4m, the length of which is L, and it is what? It is hinged at the midpoint. A ball of mass m moving with a speed v. So there is a ball which is moving at an angle of 45 degree of mass m with a speed v. So we can break the velocity component into two parts. One velocity will be perpendicular to the rod, which will be v by root 2, and the other will be parallel to the rod. That velocity will not account for any angular momentum. Alright, so I'm going to use the conservation of angular momentum here. So angular momentum before collision is m v by root 2 into L by 2. Alright, so this is the angular momentum before collision. After collision, the particle sticks to the rod. So the moment of inertia about an axis passing through midpoint and perpendicular to the rod, that will be mass of rod into L square by 12. That's the moment of inertia of the rod. I will add to it the moment of inertia of the particle, which will be m into L by 2 square. So this becomes the moment of inertia of the entire system now. Alright, into omega. So angular momentum before collision, angular momentum after collision. Those of you who have attempted today's first shift and did this question wrong, in my opinion, the mistake that you would have made is to write an m here. Alright, that's in our habit. When we try to recall the moment of inertia of a rod or any other object, we recall that formula and we write it down as it is. Like people would have recalled that the moment of inertia of the rod about the perpendicular bisector is ml square by 12, and in haste or due to exam pressure, we often tend to write that same thing here, and that leads to careless mistakes. So writing moment of inertia during exams is a very important step, and you should be alerted whenever you are required. Like you should alert yourself, right? Your mind should raise an alarm whenever you are about to write moment of inertia, that you have to be cautious, you are substituting the mass carefully. And use of bracket, the habit to use brackets while writing masses or while substituting values, like I have done here. See, I have written 4m in the bracket, I have written the distance of particle from the axis in bracket. This habit can increase the probability of getting the things correct. Okay, so we can avoid careless mistake by developing good problem solving habits, and use of bracket is one such habit. All right, so when we solve this one, we get the correct answer. All right, possibly you'll get this value, I'm not sure. I guess A option will be there, so you can just solve this and you can check it out. All right guys, okay, so moving on to the next question. Now this question says that there are 2 photons of energy, 4 electron volt and 4.5 electron volt. Now guys, this question is a little bit complicated one. There's a lot of information given in this question, and we have to actually understand that information carefully before we start solving this question, because the solving part is not difficult, but we have to grasp what the information that is given in the question. So question says there are 2 photons of energy, 4 electron volt and 4.5 electron volt, and they are incident on 2 metals. So at least we can start by drawing 2 metal plates. Now one of the metal plate is A and the other metal plate is B. All right, and this metal plate is irradiated with light. All right, with light having photons of energy 4 electron volt. This metal is irradiated with light having photons of energy 4.5 electron volt. So this much part I have understood. Now maximum kinetic energy of the ejected electron, TA for A. So there is, the electrons are ejected from both the plates, and some relation has been mentioned between the kinetic energy of both the situation, maximum kinetic energy seen in the electrons. Now relation between de Broglie wavelength of the ejected electron. So there are 2 kinds of relation given, right? Electrons are emitted from here, and the kinetic energy of these 2 electrons, some relation has been mentioned there, and some relation has been mentioned in the de Broglie wavelength of these electrons. So I guess these 2 information, like this and this one, this is sufficient for us to get the exact value of kinetic energy. Let's see how. So first of all, the question says that lambda B is equals to 2 lambda A. Now lambda can be written as H by P. All right, so 2 times of H by PA. So it means the momentum of A is 2 times the momentum of B. That is one thing. Now kinetic energy, which is indicated by alphabet T in this question, kinetic energy can be written as square of momentum divided by 2m, right? This is a general formula, not specific to this case or not specific to this. This is general formula. Kinetic energy can be written as square of momentum divided by twice of mass. So this tells me that the ratio of TA by TB should be equal to PA square by PB square, as mass is same for both are electrons. So PA by PB is how much? PA by PB is 2, square of that will become 4. So from here I know that the kinetic energy of A is 4 times the kinetic energy of B. So we can put this here. The question says, like, instead of TB, I can put TA by 4. So TA by 4 is equals to TA minus 1.5. On solving this, what will I get? This will become 3 TA by 4. 3 TA by 4 is equals to 1.5. Which means TA as how much? Which means TA is 2. So if TA is 2, TB will be how much? TB will be TA minus 1.5. So TB is 0.5. Okay, so we have obtained the value of TB. We have obtained the value of TB. Now question is asking for the work function of B. The work function of B. How do we find work function? The energy of the incident photon minus the energy of the electron, that becomes the work function, right? The energy of the incident photon, it is divided into 2 parts. One is the kinetic energy of the electron, and the other is the work function. So the work function should be 4 electron volt, right? The work function will be 4 electron volt. All right, is that okay? Everybody got this one? All right. So let's remove this one now. This was a good question. By good, I mean this was a question that will consume some time in the examination, and it would have been a good strategy to leave out this question initially, right? Once, so long as there are some questions left in the paper of whichever subject, you should skip such questions. Like one such question I came across in yesterday's paper also, when I was discussing the Shift-1 of yesterday. In that, a gravitation question was there. So that was a question that could have been avoided in the first attempt. You could have come back to this question after you have attempted every section, like all the subjects. Okay, this was another such question. It can be done, solvable, but it consumes time that can lead to a loss of rank. All right. Okay, so with that thought, let's move to the next question. Let me just have a look at the chats, how things are going at your end. So Mukesh is asking me about shift 2 something. I guess Mukesh, shift 2 will be done tomorrow in the morning. Okay. All right. Selva is asking me to explain question number 8 again. Selva, you can always go through the replay. All right. All right, guys, I guess that would be enough for now. Let's move to the next question. Now, question number 9 says what? There is a potentiometer wire of length 1200. Guys, just have a look at this question, how I'm going to solve this question. Okay, this question says that we have a potentiometer wire, the length of which is 1200 centimeter. All right, and some current is given. The current running through this wire is given to us, and the question says that a battery of 5 volt balances against a length of 1000 centimeters. So actually this is not important, like what is the internal resistance of the battery. Since the battery is balanced, internal resistance will not play any role. So there is a battery of 5 volt and it balances against a length of 1000 centimeter, right? Now we can obviously go by the usual method, but just when I checked the values, like when I had an initial look at the values, it was evident that if I divide this 1200 into parts of 200, so 6 parts will be formed, right? 3, 4, 5, and this will be the 6th part. So if this 1200 can be divided into 6 parts of 200 centimeter each. All right. So 5 such parts, right? 5 such parts constitute 1000 centimeter. So this 5 volt is divided among these 5 parts. So 1 volt here, 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 which obviously means 1 volt here, right? So the total potential difference across this wire is 6 volt. So total potential difference upon the current flowing. All right, this gives you the resistance. That's it. All right, of course we can do the question in conventional way also, but the values given in the question are so conspicuous, like they are it's so obvious. It seems like we can divide this length into 6 parts of 200 centimeter each. All right, and 5 such parts, they balance 5 volt. So 1 part is equal to 1 volt. So this 6th part, add this 6th part, so the total potential difference is 6 volt. That's it. The question is done. All right, guys. Okay, understood this one. Let's get to the next question now. Let's get to the next question. This question says a telescope has magnifying power 5 and length of the tube is 60. Such a question appeared in the morning shift of previous yesterday also. So a question has a magnifying power of 5, length of the tube is 60, focal length of the eyepiece. Okay. So first of all, let's understand the working of a telescope. Like ya to yaad ho, either you should remember it, and if it's if you don't remember it, it works like this. The first lens, that is the objective length, it creates an inverted image at the focal plane. So this distance is the focal length of the objective lens, right? Okay, so it creates here. Now the second lens that we keep here, it acts as a magnifying glass, a simple magnifying glass or a simple microscope, and produces a magnified image. So if we want these telescopes to be set up in the far point adjustment or in the normal adjustment, then we maintain this distance as the focal length of the eyepiece so that the image can be formed at infinity. All right, this is the theory of telescope. All right, this is something that I'm expecting you to know. This is not something that I'm trying to explain you here. All right, you should have been aware of these things. I'm just trying to recollect the things so that in case if you have forgotten, you are able to relate. So first lens makes an image in the focal plane of itself, and to get the final image at infinity, we ensure that the same location is the focal length of the eyepiece also, so that final image is formed at infinity. Now the distance between the two lenses is what? The distance between the two lenses is the sum of the focal length. All right, distance. So f0 plus fe is given to be 60 centimeter. That's one equation. all right, and the magnification that we get in this case, all right, the magnification that we get, it's f naught by fe. Why? Because this size will be written as, if this angle is alpha naught, this size will be written as alpha naught into f naught. Okay, and right, so this will be the size, and this angle will be how much? This angle will be, yeah, so this is what you're going to get. Okay, so this value is given to be 5. That's it. F naught can be written as 5 fe. All right, we can put 5 fe here in place of f naught. So that gives us 6 fe is equals to 60. So fe is equals to 10. And the question is asking for focal length of eyepiece. So 10 centimeter would be your answer. All right, getting this one? So again, you should be aware of theory to address this question. Okay, getting this, everybody? Moving to the next question. Okay, an easy question, but I generally see that the students struggle. The moment they are given the graph, they start struggling. Probably it has got something to do with psychology, maybe. Okay, now this question says that this is the graph indicating two spherical bodies of mass m1 and m2 having radii 1 and 2. So it's pretty obvious that this peak, it will come in the larger radius sphere. Okay, so I'm going to write gm2 by 2 square. All right, that's the gravitational field at the surface of m2, that is given to be 3, and I'm going to write gm1 by 1 square, gm1 by 1 square as 2. Just like this, the question says that the sphere of mass m1 is producing a gravitational field of 2 units at its surface. So I've written this, gm1 by radius square is equals to 2, and the graph says that the sphere of mass m2 is producing a gravitational field of 3 units at its surface. So I've written gm2 by 2 square, that is the radius of the larger one, is equals to 3. We have to find out the ratio m1 by m2. So you divide the second equation by the first equation. So we end up writing m1 by m2 as 2 by 3, and on this side, when I divide by m2, 4 goes in the numerator. So we end up getting m1 by m2 as 1 by 6, I would say. So 1 by 6 would be the correct answer. Getting this one? Easy question. All right. Okay. Shiva is saying tomorrow exams are, which is useful topic to learn. Shiva, go to sleep. What are you saying? What are you going to learn now? It's only going to lead to panic. All right. Just go to sleep. Good night. All right, guys. I'm moving to the next question now. Okay, so next question says, when a proton of kinetic energy 1, guys, this is a purely calculation based question. This is a purely calculation based question. You have to just first of all, see, in this question, the first thing that you should do, pay attention to the options. Pay attention to the options so that you know what you are looking for. All the numbers are same, 71, like 71, 71, 71, 71. It's only the order that you want to check. All right, so do not get involved too much into the calculation. Use approximations, use justifiable approximations. You have to figure out the power of 10. That's it. Okay, so how do we do this question? The question says that when a proton of kinetic energy 1 MeV is moving south to north. So let's say this direction is north, right? The board direction is north. My hand is pointing towards north. The camera is in south. So south to north is this direction. Okay, this is south to north. So a proton is moving from south to north and magnetic field is from west to east. Now, if that is north direction, then this will be east direction. Okay, if that is north direction, so west to east. So magnetic field is this direction. So basically, velocity is in this direction, magnetic field is there. Okay, velocity there, magnetic field. So proton will feel a force in the downward direction. But in any case, the direction is not relevant in this question. What is relevant is the amount of magnetic field that we have to calculate. So the magnetic force that the proton will feel will be QVB. The angle between velocity and magnetic field is 90 degree. So we have to equate this with mass into acceleration. All right, now one thing that comes to my mind is, are we supposed to consider the force of gravity on the proton, or are we supposed to ignore it? Can you guys give me some answer in the chat? What do you think, guys? Should we consider the gravitational force of Earth on the proton, or should we ignore it? And the answer lies here. The proton is suffering an acceleration of 10 raised to power 12. All right, now this much acceleration, understand this, the acceleration due to gravity is negligible in comparison to this. So just ignore that, alright. The acceleration due to gravity will be negligible in comparison to this. So this force is producing this acceleration. If we start considering mg also, like if I add an mg here or if I subtract an mg here, that mg will be negligible as compared to ma. So just ignore it. Okay, now how do we solve this question? So Q is, I'm going to show the calculations to you. So 1.6 into 10 raised to power minus 19, that's charge. V, I will figure it out, into B, mass is 1.67 into 10 raised to power minus 27, that's mass of proton. Acceleration is given to be 10 raised to power 12. So this product VB, let's try to find the value of this product. This 1.67 and 1.6, we can just cancel them out. It will not create much of a difference. Again, keep in mind that we are looking for power. We are not looking for the exact numbers. We are just trying to figure out the power here. Alright, so VB, and this becomes what? This is 10 raised to power minus 27. This becomes 10 raised to power minus 15. So it becomes 10 raised to power 4. Just let me just be sure that I'm doing the correct calculation. So it's minus, yeah. So this is what we are getting here. Now for V, what can we do? Half mv square is given to be 10 raised to power 6 into 1.6 into 10 raised to power minus 19 joule. So this is half mv square. So V can be written as 2 times, like root of 2 times of this number, which is 1.6 into 10 raised to power minus 19, minus 13 it becomes. Alright, divided by mass. Mass is 1.67 into 10 raised to power minus 27. So that's V now, into B is equals to 10 raised to power 4. So again we can cancel out these two. So this becomes what? This becomes 10 raised to power 8. It goes out. So we are getting 10 raised to power 4 into root 2, which is 1.4. Alright, into B is equals to 10 raised to power 4. This will come to the numerator. Okay, have I made some mistake? I feel I have done some mistake there. 10 raised to power minus 13, 10 raised to power minus 27 will come to the denominator. It will become 10 raised to power 8. Actually it was minus 4, I guess, huh? 10 raised to power minus 8, no. Not able to get that. I did, guys. 10 raised to power minus 16 is fine. VB is what you want to find out. This is 10 raised to power minus mass into acceleration, which is given to be 10 raised to power 12. So when I do the calculations, I cancel out this one. So minus 8 it becomes. 4 will be left here, that is fine. 2 into 10 raised to power minus 13. So 10 raised to power 8. What value am I getting? I am getting all the options are okay. So I think, yeah, everything is okay. This will get cancelled. 1 by 1.4, that will be close to 0.7, I guess. So all the options are in millitesla. So this one seems to be the correct one, I guess. Alright, I'm not very sure about, like, I think this should be the correct answer. Somehow I'm doubtful about my calculations. Alright, I hope you are not so doubtful, but I guess this will give you the answer. So this 710 MT should be the correct answers. Alright, okay. Did I miss the power? Where the power is 7? Okay, some students are telling me something. Minus 8, and this will become 4, and this will become 10 raised to power. Where Shiva, where power is 7? Come on guys, help me. Which power have I missed? Minus 15 QVB equal to MA 10 raised to power 10.6 19. Where have I missed? In the root. (13) and 7. The difference of 13 and 27 will be how much? It will be 14, not 10 raised to power 14. Okay, yes guys, thank you. Yes, this will be 10 raised to power 7 will come out from here. So we will have a 10 raised to power minus 3 here. So that means millitesla, 0.7 milli Tesla. 0.7. So this one would be the correct one. Okay, thank you guys. Thank you so much. I guess, yeah, thank you guys. Whoever pointed it out, thank you so much. Okay. All right, happens. Okay, guys, so let's move on. Okay, now this question says if the electric field around a surface is given by, see, now this question is a theoretical one, slightly difficult, you may find this one. It says electric field around a surface is given by, see, check this one, this is actually sigma by epsilon naught, right? What is written here is mod of electric field is sigma by epsilon naught. All right, now such a situation appears when the question says that this Q encloses the charge enclosed by the surface. So this relation of Gauss law is valid when surface is equipotential. See, only being equipotential will not give us this result. All right, only being equipotential is not going to give us this result. Magnitude of electric field is constant. So I guess these two conditions have to be satisfied simultaneously. Like magnitude of, see, to do this question, you should recall where we get these expressions. We get such an expressions outside, like if we are discussing situation just outside a conducting surface. Okay, so just outside a conducting surface, the electric field lines, they are normal, and at such points we write electric field as sigma by epsilon naught. Or when we are discussing infinite sheets, infinite conducting sheets, we write electric field like this. So in both scenario, what I can see is that the electric field in this region is treated as a uniform field. Like if I am drawing a Gaussian surface like this, we consider the electric field over this Gaussian surface to have a constant magnitude and same direction, we consider it as a constant value. So the surface would be an equipotential surface here, over which we are writing the Gauss law, and the electric field will be constant in magnitude. So out of these given options, C option would be the best one. All right, right. Okay guys, so theoretical question it was. Let's move to the next question. This question says stopping potential depends on again guys, now this is a question that can really kill your time. Why? This question is for dimensions, right? Dimensions. Okay, we look down upon that topic, that this is an easy topic, this is so easy a topic. If a question comes from this, we are going to address this. All right, but this question can really consume your time if you do not proceed in the proper way. All right, so I'll tell you a short trick. I'll tell you how to do this question without getting stuck. I'm giving it as a challenge to you that you try to do this question by the conventional method and you start noting the time, how much amount of time you spend in doing this question, and you will realize that if you do it the conventional way. What is the conventional way? Where we write that we want to find the stopping potential, so we express stopping potential as h raised to power a, I raised to power b, g raised to power c, and like that. All right, and then we try to figure out the value of the exponent. So that will just kill your time. Okay, you will be getting the final answer. I'm not saying that you will not be able to solve it. You will be able to solve it, but the time that you are going to spend is going to hurt you. It is going to pull you down. It is going to, like, it's better to leave this question if you are going by the conventional method. I'll tell you the unconventional method. Now, what's the unconventional method? See, if you have studied dimensions, have you ever thought about this? Like, we have figured out that there are 7 fundamental quantities. Let's think about that. Let's think about that. So long as you are dealing with mechanics, like so long as you are dealing with force, pressure, momentum, acceleration, distance, time, speed, all right, and all these quantities, like till you move to rotation, then maybe SHM, maybe waves, okay, till gravitation, you don't need anything other than mass, length and time. All right, to express the dimension of any quantity, so long as you are like kinematics, you are studying chapters like kinematics, Newton's laws, friction, work, power, energy, conservation of momentum, rotation, SHM, waves, all these chapters that do not require anything else apart from mass, length and time, so long as you are wandering in these chapters, right? The moment you enter into the thermodynamics, like temperature comes into play, so you have to now make use of another fundamental quantity, which is temperature. All right, there are certain parameters, certain physical quantities that we define in thermodynamics that are defined in terms of that uses ml, T and theta, that is temperature. Now when you go into the electrodynamics range, you start using ampere also. You cannot deal with all the quantities of electrodynamics without entering into the ampere. But so long as we are like outside the electrodynamics domain, we are free from ampere. So that's the thought process. Like these things, if they are in your mind, let's try to understand how you can solve this question quickly. The question wants to express some kind of potential, like stopping potential, some kind of potential in terms of GHC. Now think about this. Now I come to the short trick that I was telling you. This was the background that if you have this idea, when you need to when you want to invoke what kind of dimension. So this G is a quantity from mechanics. It will not contain Coulomb or ampere. It will not contain ampere. This H again expresses energy and frequency. This H relates energy, a quantity of mechanics, and frequency, again something expressed only in form of time inverse. Alright, so this can be expressed in terms of mass, length and time. This can be expressed in terms of mass, length and time. This can also be expressed in terms of mass, length and time, right? This is speed of light, LT minus 1 meter per second. This is the only quantity of electrodynamics here. So in writing the dimensions of potential, if we ever require ampere, this quantity is going to take care of ampere. This I is going to take care of ampere. Alright, for example, let me try to figure out what's the dimension of voltage. Now potential can be written as energy upon charge, right? Potential can be written as energy upon charge. Energy is the quantity of mechanics. Okay, like this is something that that can be expressed in terms of MLT, mass, length, time. Charge will be expressed as, like I will write it here as energy divided by ampere into time. Charge will be expressed as ampere into time. So this is quantity of mechanics. This is comprising of ML and T. This is T itself. So the power of ampere while expressing voltage, volt, will be -1. Okay, so search for option that contains I with a negative power of of 1. A can be a possibility. B is definitely wrong. C is definitely wrong. D can be a possibility. So out of 4 we have eliminated 2 options. Right, out of 4 we have eliminated 2 options. Now what should I do for these 2? Should I go for solving? No, don't go for solving. Once you have eliminated 2 options, just check the dimension of any one. That will be more easy. That will be easier. Alright, it's better to just check the dimension of any one option. For example, let's say since I know the answer to this question, I will deliberately choose the other one. Let's try this one. The correct answer to this question is option D. So let's try this one. Okay, H is energy upon frequency, right? So it's energy into time. Energy is mL square T minus 2 into time. That's H. I inverse is ampere minus 1. Then G1. Now G is written as what? G has units of Newton meter square by kg square. So Newton is mLt minus 2. We multiply it with length square. So this will become L cube. We divide it by kg square. So it will actually become m by 2. So okay, I'll write it here. Okay, so this is G. And then C raised to power 5. So L raised to power 5 upon T raised to power 5. Okay, so check whether we are ending up with dimensions of potential or not. Are we aware of dimensions of potential? Yes, we are. We are aware of dimension of potential. This should end up like the dimensions of potential. I'm writing it here. The dimension of potential is energy, which is mL square T minus 2 divided by charge. Charge is ampere time. So A inverse and this. So this whole calculation should end up in this one if this is the correct option. It will not happen like that. So this is also incorrect. D will be the correct one. You can check the D one also. Incidentally, if you happen to check D instead of A, you will get the answer. All right. Getting this one? All right. So if you go by the conventional method, this will kill your time. All right. The trick here was to look for the power of ampere. Okay. The power of current. That will actually reduce 2 options. The remaining 2, you can just check one of the options. All right, that will either be the correct one or that will be the incorrect one. If it happens to be the correct one, you have got your answer. If it happens to be the incorrect one, then also you have got your answer, right? So that actually makes the question easier. Now let's have a look at this one. Now this question says that a cylinder of height 1 meter is floating in water at 0 degree with 20 centimeter height in air. which means 80 centimeter is submerged, right? 80 centimeter submerged. Now temperature of the water is raised to 4 degrees Celsius, which means the density of water will increase, right? Water shows anomalous expansion. The density is highest at 4 degrees Celsius, so the density of the water will increase. All right, as a result, the height in air becomes 21 centimeters. So now only 79 centimeters is submerged. Okay, the ratio of the density of water at 4. So I'll draw the two situations. In one situation, there is a cylinder floating here, all right, with 80 centimeters submerged, and this is happening at 0 degrees Celsius. In the other situation, the cylinder is submerged with 79 centimeter of it submerged. All right, and this is happening at 4 degrees Celsius. The question says that the cylinder doesn't expand. So whatever buoyant force we write in this case, that buoyant force will balance the weight of the cylinder. Whatever buoyant force we write in this case, that buoyant force will also balance the weight of the cylinder, and the two weights are equal, right? So we are basically going to equate the buoyant force written in the two cases. So buoyant force written in this case is density at 0 degrees Celsius into the cross-sectional area. Let me write this cross-sectional area as A, into the length submerged into G. So that's buoyant force written in this case. Buoyant force written in this case will be density at 4 degrees Celsius into A into 79 into G. All right, just do the calculation, you'll get your answer. Okay, there's one thing that should be highlighted here. On doing this calculation, I'm erasing this part as this is not required anymore. So I'm erasing this part. I hope you have noticed whatever I have done. Okay. So once you do this calculation, you will end up writing what are we looking at? Ratio of density of water at 4 degrees. So we want rho 4 by rho naught. So this will be how much? This will be 80 by 70. All right, this will be 80 by 70, which clearly tells me that the answer will be close to 1. But when I have a look at the options, I can only eliminate one. I'm only able to eliminate this one because the other values, they are pretty close to 1. So what do? One thing is, it's not too difficult a division, right? You probably learn these things somewhere in your 5th and 6th class, so you should be able to do this. But in any case, if you are worried about losing your time, can we do something about this? Yes, we can. Again, one of the thing is to split 80 into 1 plus 1 by 79 and then go for division. One way is this, like from here you can start dividing. Okay, the other thing was to write 80 by 79 as 80 by 80 minus 1, which can further be written as 1 upon if I take out 80 as the common, 1 upon 1 minus 80. Now we can use binomial. So 1 minus 1 upon 80 with a power of minus 1. So this is 1 plus 1 by 80. I guess 1 by 80 is an easy calculation to do. Yes, 1 by 80 is something that you can do easily because it involves power of 2. Like that is easy to find out. Like we can write this as 1 plus 10 raised to power minus 2 into 100 by 80, which is 5 by 4. 5 by 4 is 1.25. So now it's easy to do. See this. I use the binomial theorem here. 80 by 79 written like this, then like this. Then I use the binomial theorem, and you can see like this is another way of doing it. Is it advisable to do like this? Well, if it clicks you instantly, you can go for it. Otherwise, the time that you will spend thinking of an alternative solution, that loss of time will actually already hurt you. That will hurt you. It's better to straight away go for the division. All right. So you are going to get 1.01 as the answer after rounding off. Okay, guys. All right. So let's move on. I hope you like this method. These are the subtle things that actually affect your rank. Okay. These are the decisions that we make in the examination that affect your rank. Can we learn these decisions right at the time of the examination? No. These things are to be done while you are practicing. When you are preparing yourself for the exam, these are to be done at that time. But don't be very like if you are not able to think like this, you are still very well prepared for tomorrow's exam. So don't be alarmed. All right. Okay, let's have a look at this question. The number of alpha particles deflected in Rutherford's alpha particle. Now guys, this is a question based on an uncommon formula, a formula which sometimes some of your teachers, like Some students may be aware of the formula, some may not be aware of the formula. I'll try to avoid the use of formula because that is something that majority of you will not be aware of. So I'll try to think of a way which can help me to address this question without the formula. So what I know regarding alpha particle scattering experiment, and probably you guys also know, I think this is one experiment that fascinates everybody, right? It comes right at the start of 11th standard. So at that time we are all excited regarding our studies. So at least this is one chapter that we pay attention to. All right. So in this experiment, there was the highlight of this experiment was the observation that majority of the particle went undeflected, and some were deflected by a small angle and very small number was deflected by a large angle, right? I hope you remember this qualitative description of what happened when Rutherford conducted this experiment. Like, this was the observation. This is the observation that is taught in schools, that is taught in coaching institutes, that is taught to students without going into the formula. So I'm not going into the formula. You are told majority of the particles go undeviated, some are deflected by small angles, and very few are deflected by large angles, like very few particles return back. Okay, now this question says that the deflection angle is theta. So we are expecting that when theta is low, when theta is close to zero, the number of particles, such particles would be very high. All right, would be large. Majority of the particles will go undeviated. So when theta is close to zero, the number should be high. All right, and as theta is increasing, the number should go down. Because deflection is becoming large, the number of such particles is coming down. So as theta is increasing, the number should go down. So that rules out certain options. That rules out this possibility. Because it shows that the number increases, then it decreases. So such a pattern doesn't happen. Now we have two options. All right. Linear is something which shouldn't be there. Okay. Linear is something which shouldn't be there. Why? Well, if it was a linear thing, it would be like, we would have taught this to you, like your teachers would have taught this to you if the variation would have been linear one. Why skip such thing? Why skip such a small thing? Like, you are not taught this, probably you are not taught this. If it would have been a linear curve, I'm pretty sure everybody would have been aware of that. So that's one logic. The other logic is, again, it's not a linear thing because the angle, it's not like that. Like, angle is increasing, the deflection is increasing, the number of particles is going down. It's not like that. That nature is that, but it's not a linear curve. So the most obvious answer, or the most appropriate one, or the most probable one that one should select if you are not aware of the formula is the B option. All right, guys. So like this, you could you can argue like this, based on what you know already. You can sometimes make intelligent choices, and that will probably give you the correct option. All right, so let's move forward. How many of you are aware of the exact formula here? Anybody aware? Okay, Mahua Bhattacharya says that you were confused. Again, Mahua, kabhi is tarah bhi socho, like think like that also. If it would have been a linear thing, you would have known this. We would have definitely taught this to you. You would have come across somewhere in some book, in some question, in some test, in your school, in your coaching institute, somewhere you would have come across this thing. Okay. All right, guys. So Priya is aware of the formula. Nice, Priya. And Prem has given me the formula correctly. Prem, well done. Very good. Okay, guys. Let's keep moving on. Janjay Rathor. Hi. Now that's my name from my previous organization. All right, Janjay. How are you doing? Okay, moving to the next question. So, if relative permittivity and again guys, now this is a question which is based on this particular formula. Okay, this formula is a common one. One is generally taught this formula, like speed of light in a medium is 1 by root of mu into epsilon. Like, mu is the permeability of the medium and epsilon is the permittivity of the medium. So this is the expression for speed of light in that medium. Now the question says that the relative permittivity and relative permeability. So I can write mu as mu naught into mu r. So relative permeability is given to be 4 by 3. All right, and epsilon can be written as epsilon naught into relative permittivity, which is given to be 3. All right, so we cancel these two things and we end up writing 1 by 2 root of mu naught, and this is what? This is speed of light in vacuum. So 1 by 2 into c. Now that clearly tells me that the refractive index is 2. All right, like speed in a medium is written as c by mu. So the refractive index is 2. And how do we write the critical angle? The critical angle is written as the rarer medium, all right, which we are considering as vacuum or air. generally when we talk about critical angle, we should give the pair. We should mention critical angle of glass and water. All right. We should mention both the medium, but when it is not mentioned, we assume vacuum as the default other medium. All right. So this sign of critical angle is written as mu rarer by mu denser. If we are comparing any medium with vacuum, vacuum is going to be the rarer medium. So I'm going to write 1 here and 2 here. So critical angle is 30 degree, right? Easy question. 30 degree would be the correct answer to this one. All right, guys. Let's move to the next one now. Now this question says what? This question says the given loop is kept in a, like, now guys, just have a look at the loop. The figure tries to depict the loop as a complex quantity. Like when I say complex, I do not mean iota thing. It's just like not a regular figure. If you watch it carefully, it's actually a regular figure. It's actually a rectangle from which 2 triangles have been removed, right? So the question says that it's kept in a magnetic field perpendicular to the plane of the loop. The field changes from 1000 Gauss. Okay, the field changes from 1000 Gauss to 500 Gauss in 5 seconds. The average induced EMF in the loop is, okay. Now one thing is, are you aware of what Gauss is? Because that's one thing that will be required in this question. Okay, so you should be aware of how much one Gauss is, but I'll try to solve this question without telling you what is the relationship between Gauss and Tesla. Why? Because I do believe that you are in habit of using Tesla and many of you are not aware of Gauss as a unit of magnetic field. Okay, so I'll try to address this question without revealing the relationship between the two. Why? Because maybe the options can help me. Even if I'm not aware of the exact relationship, maybe the options can help me. So let's try to figure it out. Okay, I can see that the microvolt is used in all the options, so maybe that can help me. Okay, let's try to do that without using the relationship. If we are stuck, I'll then reveal the relationship and I'll make use of it. Okay, so the area of the loop is what? The area of the loop is area of the rectangle, which is 64 centimeter square, minus area of the triangle. This is a triangular region. All right, yeah, this is a triangular region. So we have 2 such triangles that we have to subtract. So 2 triangles will make a rectangle actually. So half into base into height, I can simply subtract base into height. So that's 4 into 2. So this becomes 64 minus 8, that's 56 into 10 raised to power minus 4 meter square, right? So this becomes my area. Now the question is asking for the average EMF. Now how do we write average EMF? We write change of flux divided by the time taken. Now change of flux will be written as B into change of B actually. The area is not changing in this question. So delta B into area divided by time taken. Delta B is 1000 Gauss to 500 Gauss. I am not aware of what Gauss is. Okay, so let's just write it in terms of Gauss itself. So the change is 1000 and 500, difference of 1000 and 500. Again, there are no plus and minus sign mentioned here. So do not worry about whether to subtract 1000 from 100, 1000 from 500 or 500 from 1000. Do not worry about that. All right, so difference is 500 into area. Area is 56 into 10 raised to power minus 4. All right, divided by time taken. Time is how much? Time is 5 seconds. All right. So the unit here is Gauss. The unit here is Gauss, 500 Gauss. So this ends up, we end up getting what? Am I doing things correctly? Yeah. So this ends up, we end up getting this as 100. So it's actually 56 into 10 raised to power minus 2. But we have this unit is in Gauss. Like I'm not sure whether this is an SI unit or something else. Do I see a 56 in the option? Yes, I do. So am I very sure that this is the correct answer? Well, if I'm not aware of the relationship between Gauss and Tesla, I can't be very sure, because it may just happen that one Gauss is, you know, like let's say 2.5 times of something Tesla. So that will actually change this number. Unless these two are related, Gauss and Tesla, unless they are related only by power of 10, okay, this number is going to change. So can we be very confident regarding our answer? No. But that's the best you can do if you are not aware of how much one Gauss law is. Sorry, not Gauss law, one Gauss and Tesla, how they are related. So the exact relationship is this. One Gauss is actually 10 raised to power minus 4 Tesla. Yes, one Tesla is 10 raised to power 4 Gauss. Yes. So one Gauss is, am I writing it correct? One Tesla is 10 raised to power 4 Gauss. So yes, so when I change the Gauss to Tesla, we end up writing 56 into 10 raised to power minus 6 volt. So 56 microvolt will be the correct option here. Okay, so if this relationship would have included a number here, for example a 2 or a 3 or a 4 or any other thing, then 56, like some different number would have been the answer. But in any case, if you are not aware of the relationship, you should go by the best that you can do. In this question it was arriving at this value 56. That was the best that you could have done, and the rest you can leave it to your luck. All right, okay guys, moving to the next one. Okay, all right, Avik is asking me to okay guys, I'm moving a little bit faster now. Okay, I'm trying to move a little bit faster as you are requesting. So choose the correct Boolean expression. So guys, this expression is actually an OR gate, right? This part constitutes an OR gate, because if you close this one, then this diode becomes in forward bias, current flows. If current flows here, so that means like this entire thing becomes a connecting wire. So 5 volt reaches here. If this is closed, the same thing happens. If both are closed, the same thing happens. So if any one or both are closed, we get a high value here. So this part is representing an OR gate, and this is a setup for a NOT gate. All right, so this is OR followed by a NOT, which is what? NOR gate. So the output of a NOR gate is what? The output of a NOR gate is A plus B complement, which is A complement dot B complement. Let's look for the options. It's D option should be the correct one. It's OR followed by NOT. So A prime dot B prime should be the correct option here. All right. Okay, let's move to the next one. Let's do it quickly now. Solid sphere of density. So guys, we have been given a sphere, the density of which is varying. The density is variable, and the question says it just floats in the liquid, which means the average density of the sphere is same as the density of the liquid, and we have been asked the density of the liquid. So you have to just calculate the average density. So average density is given by mass upon volume. So mass can be calculated as density into 4 pi r square dr. Integration of this from 0 to r divided by the volume, which is 4 by 3 pi r cube. Just check this. What I have done here, if this is a sphere with a varying density, then at a distance r, I have considered a spherical shell of width dr. Now this volume will be written as area into the thickness. Area is 4 pi r square, thickness is dr. So we do this calculation. What kind of calculation? You put this value here and then you integrate. Okay, I'll just finish this off. This 4 pi will go out of the integral. It will get cancelled. All right, instead of rho, we are going to write this. So rho naught will come out. Okay, and now we are integrating this thing multiplied with r square. So we are going to get r cube by 3 after putting in the limits, and the other quantity will be r raised to power 4. So r raised to power 5 divided by 5, and this r square will stay here, and we divide everything by r cube by 3. All right, into rho naught. You solve this thing, you are going to get the result. I have done few things, 2-3 mathematical steps mentally. What I have done, I have r square I have taken here. So this becomes r square, this becomes r raised to power 4 divided by capital R square. When I integrate this, the r square gives me r cube by 3. The r raised to power 4 gives me r raised to power 5 by 5. The r square remains as it is. Finish this calculation, you are going to get the result. All right, getting this one? Okay. There are some students who are asking which shift is this. This is the morning shift of today's paper. Today's morning shift. All right, guys. So the next question: two particles each of mass this much are moving with the velocity this and this. After elastic collision, so guys, this is a simple question. There are two particles. Just a minute. One particle is coming like this, the other one is coming like this. They collide, and one of the particle goes like this. We are looking for the kinetic energy of the other one. Since the question says the collision is elastic one, we can conserve the kinetic energy. So this has a mass m, this has a mass m. So initial kinetic energy was half m into speed square. So that is 9 square of 3. Then the half m 5 square. 5 square will become 25. Okay, this equal to half m. One of the particle is moving with a speed of with a velocity of 4 I cap plus 4 j cap. Now what is the speed of this particle? It's 4 root 2. So square of 4 root 2 will become 16 into 2, that's 32, plus kinetic energy. This kinetic energy is what we are looking for. Okay, you bring this to this side, You will get the kinetic energy in terms of mass. Mass is given to us, put it there, you will get a numerical value. You can then compare the numerical value by x by 10 and you will get the value of x. You are going to get x as 1 once you finish the calculation. Alright, okay, so let's move on to the next question now. This question says a plano convex. I don't think anything can come simpler than this. Like people who have attempted today's morning shift, probably they would have read this question twice just to confirm that such an easy question can also come in the examination. Now, this question says that there is a plano convex lens and the radius is given to us as 30 centimeter. Okay, the refractive index is given to us, focal length has been asked, so you just use the lens maker formula, which is this. Alright, 1 by r minus 1 by infinity, because one of the surfaces is plane. So you get the result as this mu minus 1 is 0.5, 0.5 by 1 by 30, 1 by 60 is your answer. Just put the numbers, get the value. Alright, clear? Okay, I think some students are waiting for second shift. Second shift will be done tomorrow morning, not today. We'll be discussing the second shift tomorrow in the morning. Today's second shift will be discussed tomorrow in the morning. So guys who are waiting for that, please don't want to keep you waiting and then disappoint you. So we are going to do that tomorrow in the morning. All right. Okay, so let's move to the next question now. Position of two particles A and B as a function of time. Guys, these questions are very easy. Position is given as a function of time. You differentiate this one, you get the velocity of A. You differentiate this one, you get the velocity of B. The velocity of A with respect to so that's very simple, I guess. You just keep on doing whatever is mentioned in the question. To get velocity of A, I differentiate this one, I end up writing minus 60 plus 8. Alright, and for specific time of t equal to 1 second, this becomes 2. Okay, now if I am writing velocity of B, I differentiate this one to get minus 24 t square, which is minus 24. Okay, but the thing is, this is written in terms of x, this is x, this is y. So this, if I write the velocity vector, this is I cap. If I write the velocity vector, this is j cap. Actually, this is a trick here. This is a trick here. People who will fail to notice this, they will err. They will commit a mistake here. Okay. So the relative velocity of B with respect to A. So VB minus VA vector. VB minus VA will be minus 24j minus 2i, and we are looking for mod of this. So mod of this will be root of 24 square plus 2 square. This mod is indicated as root V. The question says that the velocity of B with respect to A is root V. So the speed is root V. So V turns out to be 580. Just check this. 24 square is 576. So V is 580. Getting this one? All right. Okay. Many students are asking for PDF. I'm not able to get that, like what you are asking for, like all right. Yes, Sylvie, shift 2 will happen tomorrow morning. Yes. All right, tomorrow morning shift 2 of today paper, and tomorrow evening we will be doing shift 1 of tomorrow's paper. Okay. So the second last question, let's do this. An open organ pipe of length 1 meter contains an ideal gas whose density is twice the density of atmosphere at STP. Find the difference between the, okay, now let's try to do this question. See, speed of sound in air will be written as bulk modulus upon density of air, right? Now speed of sound in that particular gas, an ideal gas, name is not mentioned, this will be written as bulk modulus divided by the density of the gas, which is 2 times the density of air. So I can write this as 1 by root 2 into root of B by rho air, alright, which becomes 1 by root 2 of 300. Alright, so this is what it becomes. Now the question is asking me find the difference between the fundamental and the second harmonic frequency. Okay, it's an open organ pipe. So for open organ pipe, the fundamental frequency is this much. Alright, and the second harmonic is 2V by 2L. So when I take the difference, I end up writing V by 2L only. The difference will be equal to the fundamental frequency only. So V is available with us. This is V. We have to divide it with 2 times of length of pipe. Length of pipe is given to be 1 meter. So we divide it by 2. We end up getting 150 by root 2. Alright, so just do the calculations here. Alright, like I can write it as 75 into root 2. So just calculate this value and you will get the result. All right, it will come close to around 104 and something. Okay guys, okay, chalo ab last question dekhte hain. 4 resistors 15, 12, 4 and 10. So let's draw them. All right, 15, 12, 4 and 10 arranged in the cyclic order. So we can so if I call this as 15, this is 12, this is 4 and this is 10. Okay, cyclic order. To form a Wheatstone bridge, what resistance should be connected in parallel across 10? So we want to connect some resistance here, all right, such that to balance the Wheatstone bridge. So we want to balance this one. So this bridge will be balanced if the ratio of these two becomes 3. 12 by 4 becomes same as 15 by this. So am I correct? So okay, this should become 5. The equivalent value should become 5. That's so obvious now. We want the equivalent value to be 5. If I put R as 10 and 10 connected parallelly will give me a value of 5. We don't even need to solve this question. Like it was visible orally. It was visible, like it was visible, not orally. But if you can't recognize that, write this 10R upon 10 plus R. That is the equivalent value here. This equivalent value should be 1/3 of this value, which is 5. Solve this one to get the value of R. Alright guys, so that finishes the discussion today. I hope you enjoyed this discussion.